Okay, let us continue our tutorial sessions. The next question is plot the signal x of t equal to u of t plus 1 plus 2u of t minus u of t minus 3 minus 2u of t minus 5. Let's do this. Okay, let's attempt to plot this. From the question, the first term is u of t plus 1. So let me draw u of t plus 1. This is u of t plus 1. Okay, this is u of t plus 1, which is a step signal which starts from t equal to minus 1 and amplitude 1 and extends to positive infinity. Okay, now what is the second term? What is the second term? Second term is plus 2u of t, right? Plus 2u of t. U of t means it starts from t equal to 0 and 2u of t means its amplitude is 2. Okay, let me try another color. Okay, I don't know if it is visible, maybe, right? So 2u of t means it starts from 0 with amplitude 2. Okay, again it extends up to infinity. Okay, now what is the next term? It is minus u of t minus 3, right? Minus u of t minus 3 is not plus u of t minus 3. If at all it was plus u of t minus 3, it would have been a step signal starting from t equal to 3. Okay, but it is minus u of t minus 3. Let me draw minus u of t minus 3. So it is a negative step with amplitude minus 1 starting from t equal to 3 and extending out to positive infinity. Okay, and finally there is one more signal, minus 2u of t minus 5. Minus 2u of t minus 5. So how can you plot minus 2u of t minus 5? So it is a step signal again starting from t equal to 5 and amplitude minus 2. Okay, amplitude minus 2 and goes to infinity. All right, so listen, what I have done is I have plotted all the individual components, signal components given in x of t, okay, in various colors. Now what I'm going to do is add all these, algebraically add all these signals to obtain the output. Okay, so let's do this. So initially this is the only signal and there is nothing else to add, so the sum is itself up to t equal to 0. But what happens at t equal to 0? One more signal adds, okay, whose amplitude is 2. Initially the amplitude was 1. Now an amplitude 2 step signal is added at t equal to 0. So the total sum is 2 plus 1, 3. Okay, already there was 1. Now this 2 amplitude signal is added to give 3. So 3. Okay, right. Now the signal continues. Now the signal continues as such without any disturbance. The signal continues without any disturbance up to t equal to 3. Now what happens at t equal to 3? A step signal with amplitude 1 is being subtracted. Okay, a step signal with amplitude minus 1 is being subtracted from the total. So the total decreases by 1. Okay, and then goes as such up to t equal to 5, right? Up to t equal to 5. And what happens at t equal to 5? Actually, before discussing that, what is the amplitude of the resultant signal, total signal? Now it is 2, right? 2. Okay, it was 3 at this point of time. Then at t equal to 3, 1 unit was decreased, 1 step signal was subtracted, so the amplitude becomes 2. Okay, it continues amplitude as 2 up to t equal to 5. Now what happens? Now at t equal to 5, another step signal with amplitude minus 2 is being subtracted. Okay, so what happens is what happens to the overall result is from this 2 you can see this 2 is being subtracted. Okay, and it reaches 0, and then the resultant goes like this. Okay, so the portion given in thick white line is the answer to the question. Okay, welcome to the next question. Check the periodicity of the given signals. Find the fundamental period, obviously if periodic. First question, x of t is equal to given 10 sine 25 pi t plus cos 10 pi t. Okay. Actually, there are many methods to find out or check out whether this x of t is periodic or not. First one is just look at the argument inside sine and cos. If both of them contains pi, or if both of them does not contain pi, then they are periodic, or then the signal x of t is periodic. If any one of the sinusoidal contains pi, then it will not be periodic. Okay, here both the sinusoidals contain pi, so the signal x of t is periodic. Or we can do it in the mathematical way. Okay, so omega 1 is 25 pi, you know it, and omega 2 is 10 pi. We are going to prove mathematically that the signal is periodic or not. So since omega 1 is 25 pi, then what is t1? T1 equal to 2 pi by omega 1, which is 2 pi by 25 pi, which is equal to 2 by 25. There goes. Okay, then if omega 2 is 10 pi, then what is t2? T2 equal to 2 pi by omega 2. T2 means the time period of this cos 10 pi t alone. T1 is the time period of this sine signal alone. Okay, you know that. So t2 equal to 2 pi by omega 2, which is 2 pi by 10 pi, which is 1 by 5. Okay, now we got t1 and t2. To check if x of t, the whole of x of t is periodic, we have to divide t1 by t2. Find the ratio t1 by t2, and if this ratio ends up in a rational number, then we are sure that x of t is periodic, otherwise not. So t1 by t2 is 2 by 25 divided by 1 by 5, which will give you 2 by 5, which is a rational number. Okay, 2 by 5 is a rational number, therefore x of t as a whole is periodic. Okay, so we have checked question number A and arrived at the conclusion that x of t is periodic. Now that we got the signal as periodic, our next aim is to find out the time period of the signal. Okay, there are again still many methods to find out the time period of the signal. One such method is to find time period. To find time period, find the LCM of T1 and T2. Okay, find the LCM of T1 and T2. This LCM will give you the time period of the signal. This LCM will give you the time period of the signal. Okay, so we know T1 is so we know T1 is 2 by 25, so LCM of 2 by 25, comma T2 is 1 by 5. Okay, so you have to find out the LCM of two fractions. So check out the denominators of these two. One is 25 and the other is 5. What is the LCM of 25 and 5? That is 5. So multiply both the fractions by 25. Okay, we'll do it in another ink. So we are illegally multiplying both the fractions by 25. Anyway, that will give you LCM of 2 comma 5. Okay, what is LCM of 2 comma 5? That is 10. That is definitely 10. But remember, we had multiplied by 25, so we have to divide it by 25 also. That is the actual LCM. Okay, so 10 by 25 will give you 2 by 5. Okay, so 2 by 5 is the actual time period of the signal. Or else we can have another method. I can give you another method. X of t is equal to 10 sine 25 pi by 1 t, that is not wrong, plus cos 10 pi by 1 t, that is again not wrong. Okay, now omega 0 fundamental frequency is given by HCF of the numerator inside the sinusoid, that is 25 pi comma 10 pi, divided by LCM of the denominator inside the sine and cos, that is 1, right? Denominator is 1. So what is HCF of 25 pi 10 pi? HCF is actually 5 pi. 5 pi is the highest common factor in 25 pi and 10 pi, divided by LCM is 1. Okay, so omega 0 is 5 pi. Therefore, total time period is 2 pi by omega 0, which is 2 pi by 5 pi. That will give you 2 by 5, which is same as the result we have obtained in the previous method also. Okay, so this is the answer for question A. Continuing with the question B, where you are given x of n is equal to cos pi n by 2 minus sin pi n by 8 plus 3 cos pi n by 4 plus pi by 3. You don't have to worry about whatever given in this phase. That is not going to affect our periodicity, so leave it as such. What we are interested is the omega 1, which is pi by 2, omega 2, which is pi by 8, and omega 3, which is pi by 4. Omega is the coefficient of n in cosine or sine terms. So first our aim is to check whether this signal x of n is periodic or not. For that we take omega 1 and divide it by 2 pi. What we will get is pi by 2 pi is equal to 1 by 4, which is a ratio of integers. So this term is periodic. Okay, next we take omega 2 divided by 2 pi. We will get pi by 8 by 2 pi, which will give you 1 by 16. 1 by 16 is again ratio of integers. So that will help us to judge that this term also, second term also, is periodic. Okay, similarly what you have to do is take omega 3 divided by 2 pi. So omega 3 is pi by 4, and dividing it by 2 pi will give you 1 by 8. 1 by 8 is again ratio of integers. So we can definitely say that this term, third term, is also periodic. So each of the terms in x of n are periodic. That means x of n is also periodic. Okay, so what should be our next aim? Just find out the time period of x of n. Alright, to find out the time period of x of n, we can use any method. I think I will use this method. Omega 0 fundamental frequency will be equal to HCF of the numerators divided by LCM of denominators. Okay, that is from the question. HCF of numerators. What are the numerators? Pi, again pi, then pi. Okay, numerator in the first term is pi, second term is pi, third term is also pi, and divided by LCM of denominators. What are the denominators? Denominators are 2 in the first term, 8 in the second term, and 4 in the third term. So the denominators are 2, 8, and 4. Okay, so that is equal to, what is the HCF of pi? It is pi, divided by, what is the LCM of 2, 8, and 4? it would be 8. Okay, pi by 8. So what we got is omega 0 equal to pi by 8. Therefore time period is 2 pi by pi by 8, which will give you 16 samples. 16 is a integer value, so we can directly guess that time period is 16 samples. That's the final answer. Okay, let us continue. Determine whether the following system is time invariant, linear and causal. First, let us check time invariance. Okay, the given input output relation for the system is y of n is equal to x of n plus 1 by x of n minus 1. Okay, so according to procedure to check time invariance, first shift the input by n0 units. Then the output, let the output obtained is y dash of n something. So y dash of n is going to be x of n minus n0 plus 1 by x of n minus n0 minus 1. Okay, the input is shifted. The input, wherever you can see the input, here it is x of n is shifted by n0 units, means x of n minus n0. Here x of n minus 1 is there, so replace n by n minus n0, you will get x of n minus n0 minus 1. Okay, that's how we got this equation and name it equation number 1. Alright, now what is the next step? Next, shift the output signal by the same n0 units. Okay, therefore y of n minus n0 becomes, you can use this equation to evaluate. Y of n minus n0 is equal to, since it is a function in n, wherever you find n, replace it by n minus n0. So x of n minus n0 plus 1 by x of n minus n0 minus 1. So that is the equation we got when we shifted the output also with the same n0 unit, and give it equation number 2. Now observe the RHS of equation number 1 and equation number 2. Are they same? Of course they are same. That means the system is, since equation number 1 is equal to equation number 2, the system is time invariant. The input follows the output. The output follows the input. Okay, whatever variation is given in input, the same variation is given in output also. Okay, so the system is time invariant. Next, we go to check the linearity. So linearity is going to be checked for the system. So linearity checking has also got a procedure. First, what is the first step? First, take the input as weighted mixtures, a weighted sum. So I'm taking input x of n. X of n is the input, so input x of n is weighted and is being mixed. Okay, there are two signals. The first one is weighted with a1, second one is weighted with a2, and both these weighted signals are summed. Okay, added. Okay, and now I have to be very careful. This question is a typical one. In the input output relation, there is an x of n term and x of n minus 1 term. We have x of n here, right? We have x of n here. So what is x of n minus 1? Oh, we can find out. Therefore x of n minus 1 will be equal to, keeping the same weighting and mixing up, x of n minus 1 will be a1 x1 of n minus 1 plus a2 x2 of n minus 1. Okay, so wherever you find n, replace it by n minus 1 to get x of n minus 1. Okay, now we have taken the input as weighted mixture. So now we find the output. Okay, now we find the output for the weighted input. Let me take it as some y dash of n. So y dash of n is equal to Now we have x of n in the equation, but x of n is weighted mixture as given in this equation. So let us write that equation. A1 x1 of n plus a2 x2 of n. Okay, plus what is the next term in this equation? It is 1 by x of n minus 1. Do you know what is x of n minus 1? Okay, so we can write 1 by x of n minus 1 as 1 by x of n minus 1 is from the second equation, this equation, it is a1 x1 of n minus 1 plus a2 x2 of n minus 1. Okay, so let this be equation number 1. This equation or this output is obtained when the input is taken as a weighted sum. Okay, now what is the next procedure? Take output as weighted mixture, weighted sum. Okay, that means we have to find out a1 y1 of n plus a2 y2 of n. Okay, since y of n is equal to x of n plus 1 by x of n minus 1, y1 of n will be a specific case which can be written as x1 of n plus 1 by x1 of n minus 1. Okay, similarly y2 of n should be obtained. y2 of n is equal to x2 of n plus 1 by x2 of n minus 1. Okay, let us proceed now. That is equal to a1 into y1 of n is, as I have told you, it is x1 of n plus 1 by x1 of n minus 1. Okay, plus a2 into y2 of n is x2 of n plus 1 by x2 of n minus 1. Okay, let us rearrange it. a1 x1 of n plus I'm taking this term a2 x2 of n plus a1 by x1 of n minus 1 plus a2 by x2 of n minus 1. Okay, this is equation number 2, which is obtained when the output is now mixed or weighted sum. Now let us watch equation number 1 and equation number 2. Let us observe equation number 1 and equation number 2. Are they same? No. However hard we try, we cannot equalize equation number 1 RHS and equation number 2's RHS. So we have to conclude that equation number 1 is not equal to equation number 2. That implies the system is not linear. System is not linear. Alright, next is checking causality. That's the third condition. Checking causality is very simple here, because the input output relation is y of n equal to x of n plus 1 by x of n minus 1, where there is no any term which indicates the dependence of input in its future, like x of n plus 1 or x of n plus 2 something. There is no future terms of the input associated in the input output relation. That means the system is causal. Okay, so that ends that question. Let's jump on to the next question. Evaluate the following integral over minus 10 to 10 cos pi t into del of 2t minus 10 dt. So evaluating this integral can be very simple if you implement the properties of impulse function. Okay, I think we can use two properties. First property is del of at. If you find out del of at, you will end up in 1 by mod a into del of t. Okay, the next property is the shifting property of impulse, which states that integral over minus infinity to infinity x of t into del of t minus t0 dt will be equal to x of t0 into integral minus infinity to infinity del of t minus t0 dt, and this value inside the integral will be 1. Okay, or the value in the integral represented as the integral will be 1. So the answer will be x of t0. Okay, this is a shifting property of impulse. Or in other words, you have to remember this property very well. Just by hearting this property may lead you to end up in error. So you have to understand this property very carefully, because del of t minus t0 means this impulse locates only at t equal to t0. Okay, it is not in origin. It is del of t delayed by t0 units to the right. So this impulse signal is located only at t0. Okay, so when you multiply a signal, whatever be the duration of the signal, maybe it is right-sided, maybe it is left-sided, maybe it is both-sided, maybe it is an infinite duration signal, whatever be the signal, when this signal is multiplied with an impulse signal which is located at t0, this entire signal loses, right? This entire signal loses, and what remains is just an amplitude of that signal. Okay, x of t and x of t0 are entirely different. X of t is a signal, it is a function, it is a graph, it is a vector, but x of t0 is only a scalar amplitude or value of this function at t equal to t0, right? X of t0 is an amplitude of this entire signal only at a t0. Okay, so that is the end result. So if you multiply any signal with the del of t minus t0, you will end up with this signal's amplitude at t equal to t0. Okay, that is shifting property, well explained. Now let us come back to the question. You are asked to find integral given by minus 10 to plus 10 cos pi t into del of 2t minus 10 dt. Okay, so this is equal to, I can rewrite this integral as integral of minus 10 to 10 cos pi t into del of 2 times t minus 5. Is that right? Right. Del of 2t minus 10 is same as del of 2 into t minus 5. Okay. Now I'm going to apply this property, del of at equal to 1 by mod del of t, which is integral cos pi t into, okay, what is this is of the form del of a into t. Okay, right. So that ends up in 1 by mod a, mod 2 or 2 into del of t minus 5. Okay, 1 by 2 del of t minus 5 dt. This 1 by 2 is a constant, so this is integral over minus 10 to 10 cos pi t into del of t minus 5 dt. Alright, that is equal to 1 by 2 into, so now this integral is of the form where we can directly apply the shifting property. Okay, so this is x of t into del of t minus t0. t0 is 5, so the answer will be 1 by 2 into cos pi into 5. Okay, x of t0 means the signal's amplitude at t equal to 0. Okay, so I am getting this signal, cos pi t is the signal here, cos pi t, amplitude of cos pi t at t equal to 5 is equal to cos pi into 5. Okay, that's written here, cos pi into 5. And what is 1 by 2 cos 5 pi? Cos 5 pi is always minus 1, so this is minus 1 by 2. So the result of this integral is minus 1 by 2. Alright, let's work out the next question. What is the output sequence of an LTI system with impulse response h of n equal to sequence 3 2 to the input x of n equal to sequence 1 2 3 3? There is no indication on where the sample at n equal to 0 is, so we can default take the first sample as at n equal to 0. And we have done pretty much problems on graphical solution to convolution, so I think this time we can go to tabular method. So for tabular method, what we have to do is you write the coefficients or the sample values of x of n and h of n in tabular columns. There is no any insist on the order. We can take any signal at any order because convolution is commutative. So I have taken x of n in this direction. Okay, all the samples of x of n, and now h of n in this direction, 3 and 2. Okay, now what I'm going to do is, we are going to multiply corresponding rows and columns, corresponding cells. Okay, so 1 into 3 will end up in 3, then 1 into 2 will give you 2. Similarly, 2 into 3 is 6, here's 4, 9, 6, 9, 6. Okay, now what's next procedure? We go to diagonally separate the entries in this fashion. Okay, now the next step is nothing but the answer. Y of n is equal to, in the first categorization only 3 is there, so the answer is 3. In the next diagonal partition there is 2 and 6, which will give you 8, so 8. The next one 9 and 4, which sums up to 13. Then 9 and 6 sum to 15, and finally 6. Okay, so this is the answer, and by default it should also, not by default, from the procedure it should also start from 3. Okay, let's move on to the next question. Compute the autocorrelation of the signal x of n equal to a raised to n u of n for mod a less than 1. Okay, so autocorrelation, it is the process by which two same signals are being correlated or compared. Be the definition, the procedure to find out the autocorrelation of a signal will be very much simplified if you use the relation autocorrelation of a signal is equal to, if x of n is the signal, then x of n convolved by x of minus n. Okay, this is a very important result, so that we can find out autocorrelation very simply. The concept of convolution is already known to you. We have done many problems on that. So autocorrelation of x of n with x of n is x of n convolution x of minus n. Okay, now let us start doing x of n convolution x of minus n. We have x of n is equal to a raised to n u of n for a less than 1. So x of minus n is equal to a raised to minus n u of minus n. Okay, I will call it h of n in order to avoid confusions, because while convolving x of n convolution x of minus n, you have to find out x of minus n, then we have flipped it, then we have to shift it. Okay, so that may lead to some confusion if you are using x of minus as such. So in order to avoid confusion, I am just very simply just renaming x of minus n as h of n. Okay, right, so I can write autocorrelation as x of n convolution h of n, where h of n is nothing but x of minus n, which is a raised to minus n u of minus n. Okay, now we will do actually x of n is a raised to n u of n, which is an infinite signal. So is h of n. Okay, so we cannot compute graphically, or we have to compute this convolution sum just in a way we have calculated or computed convolution integral. Okay, so we have to follow that method where we have computed convolution integral. So the first step to that is change x of n and h of n to index h of x of k and h of k. Okay, change index of the symbols, x of n to x of k, similarly h of n to h of k. Why are we doing that? again, let me tell you, this is to compute. Let gamma x of n is equal to sigma k equal to minus infinity to plus infinity x of k into h of n minus k. That is the expression we need to evaluate. So we need to find out x of k, then h of k, then h of minus k, and from h of minus k, h of n minus k ultimately. Okay, so let us see what x of k is. Okay, how will you draw x of k equal to a raised to k u of k? Listen, x of n is a raised to n u of n. So x of k is just a raised to k u of k. So to draw a raised to k u of k, we have to take a raised to k. A raised to k is an exponential signal. But listen, in the question it is given a is less than 1. Mod a is less than 1. So a raised to k is an exponentially decaying signal. Exponentially decaying signal. But it is multiplied by u of k. That means it is a decaying signal only in the right side of the time axis. Okay, so it would be like this. Okay, it extends to infinity only in the positive time axis, etc. Okay, so this is a raised to k u of k. Now next is h of k, right? In order to obtain h of n minus k, first we have to draw h of k, then h of minus k, then h of n minus k. Okay, so what is h of k? H of n is equal to a raised to minus n u of minus n from this equation. So h of k is equal to, I can write here, therefore h of k is equal to a raised to minus k u of minus k. Okay, and let us see how can we draw h of k equal to a raised to minus k u of minus k. Okay, so this could be h of k equal to a raised to minus k into u of minus k. Okay, I have drawn the signal here, h of k equal to a raised to minus k into u of k. I don't need to write u of k. Okay, wait. How did we obtain the signal? Because a raised to minus k for a less than 1 is actually an exponentially increasing signal, right? For example, if a is equal to 1 by 2, then what is a raised to minus k? A raised to minus k is 1 by a raised to k, which is equal to 1 by 2 raised to k, which is equal to 2 raised to k. Okay, so 2 raised to k is definitely exponentially increasing signal, right? Exponentially increasing signal in both directions, but you know, it is being multiplied by u of minus k. U of minus k is a step input, step signal, but in the left axis. Okay, u of n is actually like this in the positive k axis, but u of minus k is time reversed version. Okay, folded with respect to the y axis, so it comes to the negative k axis. So that is multiplied by a raised to minus k to get a raised to minus k itself. Okay, so here also I don't need to write u of k any further, because it has been truncated. The signal has been truncated due to the presence of u of k, and here also u of minus k is not needed because the signal in its positive k half or positive k axis is being truncated. Okay, so this is a raised to h of k equal to a raised to minus k. Now let us find out h of minus k. Okay, we have got h of k. Now h of minus k is to be found out. Okay, so this is h of minus k obtained by flipping or folding h of k to the right. Fine. Now the next step is to find out h of n minus k. We have h of minus k with us. Find out h of n minus k by shifting h of minus k to n units to the left initially. Initially we are assuming n is very less than 0. So initially shifting this to n units to the left. Okay, well, before drawing h of n minus k, what is the expression for h of n minus k? You know, h of k is equal to a raised to minus k. into u of minus k need not be written because we have truncated the signal. Now h of minus k is equal to a raised to k. Alright, now what is h of n minus k? H of n minus k is replace k with n minus k, a raised to n minus k. Okay, so h of n minus k is equal to a raised to n minus k, whereas x of k is a raised to k. Okay, I have drawn h of n minus k directly below in an aligned manner below the x of k to avoid any confusions. So we are drawing h of n minus k as n units shifted version of h of minus k. So sorry. Okay, this could be h of n minus k. Since h of n minus k is shifted n units, this first sample will be n. Okay, now so this is a condition. Here the output, or while evaluating the signal means x of k into h of n minus k. We have x of k here, we have h of n minus k here. Just multiply these two signals. So is the product 0? No, definitely the product is not 0, because in these portions, in positive k axis, there are valid signals. Okay, non-zero. So we can find out x of k into h of n minus k over sigma k equal to minus infinity as in this interval. This interval, how can you define this interval? This interval is where this n is less than 0. Okay, n is less than 0. So at n less than 0, gamma xx of n will be equal to sigma. What is the limit of the sigma? Limit of the sigma is the duration where the product of these two signals become non-zero. Okay, so definitely it is from 0 to infinity. It goes long. Both these signals are infinite duration signals. So the limit of the integration, limit of the summation will be from 0 to infinity. So I can write it as sigma over k equal to 0 to plus infinity x of k into h of n minus k. What is x of k? X of k is a raised to k. We have it, right? A raised to k into what is h of n minus k? Again, we have calculated h of n minus k as a raised to n minus k. So a raised to k into a raised to n minus k. So I can always write it as sigma over k equal to 0 to infinity a raised to k into a raised to n into a raised to minus k. Okay, and the sigma, the dummy variable of the sigma is k. So with respect to k, a raised to n is a constant. I can take it outside. So this is equal to a raised to n sigma over k equal to 0 to infinity. Oh, I'm extremely sorry. I have done a big mistake here. H of n minus k is not a raised to n minus k. There is a big mistake here. I'm sorry, I apologize. What we have to do is h of k. From h of k, you have to write h of n minus k. Okay, h of k is a raised to minus k. So very simple. It is h of n minus k is equal to a raised to minus of n minus k. Okay, or you can write it a raised to k minus n. All right. So I'm extremely sorry for this mistake. So this I have to change it as, okay, so this is the equation is x of k into h of n minus k. X of k is a raised to k. Okay, because here it is a raised to k. Now h of n minus k, I have to change it as a raised to k minus n. Okay, a raised to k minus n. So a raised to k into a raised to k minus n is a raised to k into a raised to minus n. Okay, and with respect to sigma over k, a raised to minus n is a constant. So I can take it outside as a raised to minus n into sigma over k equal to 0 to infinity a raised to 2k. Okay, this is equal to a raised to minus n into, how can you expand this summation? Put k equal to 0 first. So a raised to 0 plus, for k equal to 1, it becomes a raised to 2 into 1, that means a square, plus a raised to, for 3 it is a raised to 6 plus etc. and goes to infinity. Okay, so What is the answer for this? This is a raised to minus n into, this is an infinite GP with the first term 1, a raised to 0 is 1, and common ratio a square. So we have to use the expression a by 1 minus r, and since a is less than 1, a square is also less than 1, so it is safe to use that expression. So 1 by 1 minus a square. Okay, therefore gamma xx of n is equal to a raised to minus n by 1 minus a square for the interval which is n less than 0. N less than 0. Okay, this is the first case. Okay, now what is the next condition? Next condition to evaluate output, we increase n. Okay, initially n was taken very negative, so it came somewhere here. Now we are increasing n. Okay, at last if this n crosses 0, the output condition is changed. Okay, so this n is greater than 0, anywhere greater than 0, anywhere on the anywhere on the k axis but greater than 0. So the next condition is n greater than or equal to 0. Okay, all right, so this is h of n minus k for n greater than 0. So I can write n as here, right? Sorry, I can write n here. Now n is greater than or equal to 0, anywhere n greater than 0. Okay, now what happens to the expression, output expression? Gamma xs of n is equal to sigma over, what is the limit of summation now? For getting the limit of summation, just observe the product of x of k and h of n minus k. From what value of n does this product remain non-zero? It is obvious from the graph that from n to infinity, right? From k equal to n to infinity, this product remains unchanged. I mean, the product remains non-zero. Okay, in this portion less than n, the signal is 0, so the product is going to be 0. So the limit of the summation is from k equal to n to infinity. K equal to n to infinity. X of k is, it is a raised to k, and h of n minus k, we have changed it as a raised to k minus n. Okay, so listen, so this sigma becomes, the limitation is from, the variable is k, so or I think I can write one more step, k equal to n to infinity, a raised to 2k into a raised to minus n, right? This a raised to k minus n is actually a raised to k into a raised to minus n. So a raised to k into a raised to k becomes a raised to 2k. So a raised to 2k into a raised to minus n. Now this a raised to minus n is a constant with respect to the variable k. So k equal to n to infinity a to the power 2k. Okay, so this is equal to a raised to minus n into, how can we expand the summation? For k equal to n, this becomes a raised to 2n plus, next is k equal to n plus 1, right? The next index after n is n plus 1. Okay, so a raised to 2 into n plus 1, okay, plus a raised to 2 into n plus 2, and it goes to infinity. Okay, this can be written as a raised to minus n into a raised to 2n plus a raised to 2n plus 2 plus a raised to 2n plus 4 plus etc. and goes to infinity. Okay, now look at this these terms in bracket. These are actually again a geometric progression, infinite geometric progression, where first term is a raised to 2n, and what is the common ratio? Common ratio is a square, right? A raised to 2n multiplied by a square gives you a raised to 2n plus 2. Okay, so the common ratio is a square. So again, since a is less than 1, we can use the sum of infinite terms of a GP. That becomes a raised to minus n into, first term is a raised to 2n, a by 1 minus r is the expression. Okay, a raised to 2n by 1 minus a square. A square is the common ratio. Okay, so this is the output expression for the value n, interval n greater than 0. Okay, so why don't we consolidate the result we have obtained? Therefore, gamma xx of n is equal to, the first result was a raised to n by 1 minus a square for n less than 0, and the next condition is, before next condition, let me just simplify this expression once again. So I can change it as a raised to minus n is multiplied by a raised to 2n here, right? So a raised to minus n into a raised to 2n is actually a raised to 2n minus n, a raised to n by 1 minus a square. Okay, this was actually minus n, I think. Okay, so this is a raised to n by 1 minus a square. So I can write it as a raised to n by 1 minus a square for n positive. Right, now this is the final answer, but still I can again reduce this. Listen, you know the expression for mod n. Mod n is equal to n for n positive and minus n for n negative. Okay, so keeping this result in mind, now again look at this expression, right? Here it is a raised to n. Look at this numerator, a raised to n for n positive and a raised to minus n for n negative. So what is this? We can again reduce this expression as gamma xx of n is equal to a raised to mod n by 1 minus a square. This is the simplest of these expressions. Okay, so that is the final answer.